Good morning, everyone. We are about 1 minute away from 11, so I just wanted to go over some more housekeeping today. So we just ask that you guys keep yourself on mute as you're coming in and during the presentation to help with background noises. We're going to be using the chat today for any questions that you might have during the presentation. So if you have any questions or just comments during the presentation, go ahead and enter them in the chat, and we will get to them whenever we start the Q&A later during our presentation. If you want to keep your video on or off, that is completely up to you. And if you want to go ahead and take the time to introduce yourself in the chat, that'd be wonderful. We want to see who's here and where you're all coming from. And it's 11 o'clock right now, so I'm going to go ahead and pass it off to Jason Pinchback with the General Land Office to get things started.
Thank you so much, Allie. Good morning, and thank you all for choosing to spend some of your valuable time with us here as we explore more topics along the Texas coast. This is part of the Clean Coast Texas Lunch and Learn series. And Clean Coast Texas is an initiative working with the Coastal Management Program where we're trying to work with communities and help them to reduce pollution and enhance water quality, as well as sustainable drainage along the Texas coast. We're excited today to continue our exploration of water quality issues. Today's focus will be primarily looking at relationships with sea level rise and how they're impacting coastal jurisdictions. And I want to just excuse myself for one brief moment as my PowerPoint is having a small glitch. So give me just 1 second to see if I can figure this out. Thank you. The Non-Point Source Program is an effort initially originated from an act called the Protecting U.S. Coastal Waters Act. What it did is it asked coastal management programs to work collectively with their state agencies and other jurisdictions to work on non-point source issues in coastal zone areas. For Texas, we have these main areas focused on forestry, marinas, hydromodification, wetlands, agriculture, as well as urban areas. Initially, our strategy was to partner up with other state agencies and to identify program elements within existing programs. And this was successful for the most part, but there were some areas regarding urban measures that we still needed to address further. Our state networked agencies include the group right here. Each organization has its own set of authorities and jurisdictions, and we use those authorities and jurisdictions to incorporate non-point source elements into various operations along the Texas coast. Other states chose a regulatory method, but in Texas, we focused on a voluntary and incentive-based approach for this. This is very important that we are actively listening to coastal jurisdictions. We want to support local decisions. We want to improve coordination, resolve existing problem areas, as well as plan and seek funding projects together. Recognizing there were some great partnerships and leadership in the coast, we formed a collaborative with Texas Sea Grant, Texas Community Watershed Partners, and the Meadow Center for Water and the Environment. Each of these organizations are experts in their own right, and they developed resources that are focused in the same areas as the Coastal Non-Point Source Pollution Program. So we're working together to tackle issues along the coast. We've been listening. We've been asking lots of questions to try to understand what existing issues are out there. This is a word cloud from some of our meeting notes. You can see on this from some of the larger words were emphasized more so in our conversations. So we worked hard to try to establish resources that would fit the various and complex needs along the Texas coast, recognizing that there's not a one-stop shop or one specific set of ingredients or formula that works. We identified a number of resources and capacity building actions that would help with both short-term as well as long-term initiatives for each of the communities. We're still seeking partnerships. So if your community or planning COG has interest in working with us and partnering up to enhance the management of non-point source pollution, please don't hesitate to reach out. what I'd like to do next is introduce Katie Swanson, who's going to be our subject matter expert today. Katie Swanson is a Stewardship Coordinator at the Mission-Aransas National Estuarine Research Reserve. As part of the reserve, Katie promotes the importance and necessity of conservation and the environment. She works closely with the reserve partner landowners, specifically Tennessee Ranch outside of Bayside. She has research experience with marsh, mangrove, grassland prairie, and seagrass monitoring and surveying, invasive species, habitat restoration, and marine debris. Without any further ado, I would like to introduce Ms. Katie Swanson to provide her presentation.
Thank you for the introduction. It says screen sharing has been disabled.
We're not seeing it yet. You're getting a message that says it's disabled?
Oh, there it goes. Yes.
Okay.
I got it now.
It's starting to transition. Looking good.
Okay, perfect. Well, thanks for the introduction. And I'm going to talk to you guys about kind of the sea level rise impacts within the Mission-Aransas Reserve, and then also go through some water quality trends and impacts we're seeing around the reserve as well. I always start my presentations with some quick background about the Mission-Aransas National Estuarine Research Reserve. We are part of a larger reserve system. It is supported by NOAA. We have 30 other reserves within the system. Connecticut actually just came online last week, so that did bump us up to 30. But as you can see, the reserve, we're located mostly around the coast, with 2 in the Great Lakes as well. The Mission-Aransas here in Texas, we are the only one in the Western Gulf of Mexico. Louisiana is trying to designate a reserve. Currently, the hurricanes kind of keep bumping that farther down the line as they're trying to recover. But the key thing about the reserve system is that we have these protocols and goals and missions that are all kind of centralized around the system. And so the monitoring that we're doing here in Texas is being done around the country. So our rates and our impacts and what we're finding here can actually be compared to other bays and estuaries and systems around the United States. The Mission-Aransas Reserve is the 3rd largest reserve in the system. We're just over 188,000 acres. Our mission is to bring together scientists, landowners, policymakers, and the public to ensure that coastal management decisions benefit the flora, fauna, water quality, and the people in the community. We were designated in 2006. We have 4 different sectors. So I'm the Stewardship Coordinator, so I head the Stewardship Program. We have a research program. Dr. Ed Buskey here at the UT Marine Science Institute also is head of the research sector and does more of the water quality. We have education program that works with outreach, school groups, community projects, summer camps, stuff like that. And then the coastal training program, or CTP, is a really cool program. They take the science that we do here within the reserve, but then also the scientists at the UT Marine Science Institute and then anywhere, and they try to get the science into the hands of the resource managers and the coastal decision makers. And then they also take what they need, the managers, and bring that to the scientists. So they're the bridge kind of between the science and the decision makers. So today's talk, I'm going to do a quick brief introduction to sea level rise and then kind of talk about some of the modeled impacts that we have for the Mission-Aransas Reserve, and then look at monitoring and some of the impacts that we're seeing from the monitoring that we do in the habitats, but then also some water quality trends. So sea level rise, what is it? So the global sea level rise, when people talk about global numbers, they're actually referring to kind of changes in the ocean volume due to ice melt and thermal expansion, and that's the average change of all the Earth's oceans. But when you're talking about local sea level rise, you actually are connecting that number or sea level rise number to a point on land. And so local sea level refers to the height of water as measured along the coast relative to a specific point on land, as I just said. But it's water level measurements from tide stations in our reference to stable vertical points or benchmarks. And you want normally about 30 years of data to really get a good trend number. And so here's a global sea level rise chart. This graph shows the cumulative change in the world's oceans since 1880. And basically since 1880, it was pretty stable. And then starting in the 1900s, it kind of started increasing. So whenever, based on the combination of long-term gauge measurements and then also your satellite measurements kind of came into play in the 1900s. This shows kind of relative sea level rise numbers around the US coastline. As you can see, the mid-Atlantic coast and then also the Gulf of Mexico seem to be pretty hot spots for high sea level rise. But sea level rise isn't always uniform. So as I was talking, relative also brings in the idea of what your land is doing along with your water levels. So for example, in Alaska, you actually have sea levels decreasing. And that's because you have ice melting off the land, and it's actually allowing the land to kind of breathe and actually increase or expand upwards. Where in the, for example, near Galveston and in our area, we have a lot of subsidence happening along with sea level rise. So you have these higher numbers where your regional sea level rise numbers are higher. Here's just some numbers along the Texas coast. And so in Rockport, we're averaging about 23 inches of sea level rise in 100 years. Galveston's at 26, and then Freeport and Port Isabella are about 17 inches for every 100 years at the current rates. Here's just a more detailed graph showing your Rockport sea level gauge. And we're averaging about 6 plus or minus 0.4 millimeters of sea level rise per year. That comes out to about almost 2 feet of sea level rise in 100 years. And when you're talking about, especially along the Texas coast where you don't have much elevation change, 2 feet can really do some inundation and damage along the coast. And then here's just kind of, again, another look at our future projections for Rockport. It does have here, the yellow line is kind of more intense, kind of worst case scenario, where this bottom line is a kind of a brighter view scenario. But either way, you're talking about 2.3 inches to 2.3 feet to almost 8 feet potentially in sea level rise before the year in the year of 2100, which honestly is getting kind of closer and closer, faster than I would like. But here, so now I'm going to talk about some of these mapping or modeling efforts that have been done within the reserve. So this work was not done by the reserve, but by partners of the reserve, and shows the reserve boundaries. And so this was a SLAM model, and it looks at how habitat and how the habitats are going to change and what they're going to change into. And so the current map, the map on our screen right now is current, and it's showing about a 0.69 meter or 2.3 feet in elevate or change in sea level rise by 2100. And so that's 2050 and then 2100. And what you're actually losing, you're seeing that we're losing a lot of estuarine beach. So on this back side, let me go back. On the back side of San Jose and Matagorda Islands, you're losing a lot of that beach. You're losing about over 10,000 acres of estuarine beach by the year 2100. We'll lose almost 19,000 acres of regularly flooded marsh habitat and 6,500 irregularly flooded marsh habitat. And that's primarily converted to estuarine open water. And your estuaries will increase by over 30,000 acres. This next project I'm going to talk about was in partnership with some of the LCCs in the USGS. And they basically wanted to look and model, they took the SLAM model and some other layers in GIS, and they wanted to see what barriers and opportunities for basically marsh migration existed in the area. And then they also took into, they also inputted kind of like urbanization and projected development numbers into the model as well. And so basically what they were looking at was they wanted to see where there was space for both marshes and mangroves to migrate, and then where there weren't areas. So this project was really trying to identify these marsh migration corridors. And so here are some of the key questions that I just went over, kind of landward migration, where are the barriers, and then how can we, are there any priority habitats or areas that we can prioritize to protect? And so this is 0.5 meters by 2100. And as you can see, there's a lot of, you really want to look at that red. That red is future tidal wetlands, but then it's also current urban habitats. And then again, you have this, a lot of increase in pink is showing where your marsh migration could potentially happen. And then the red and orange is basically where your urban or your development is meeting these migration corridors. And then here's 2 meters of sea level rise by 2100. And so here, next I'm going to talk about some of these long-term monitoring programs that the reserve has in place. And so the first one, and this is really the backbone and bread and butter of the NER program, are these sentinel sites. And a sentinel site is a specific location in a coastal and marine environment for intensive study. So basically we pick these areas of marsh and mangrove and we do intense studying. And they are part of our system-wide monitoring program, which has a number of different components. And so we have our water quality monitoring, our marsh migration or marsh monitoring, mangrove monitoring, seagrass. You have your weather stations as well, but then also part of the Sentinel site is how to get that data out into the public. And you also have the data synthesis, the mapping component as well. And so today I'm going to kind of focus on the vegetation monitoring, then go over some of our surface elevation change measurements. So if anyone has gone in the field with me, which I've had a number of people, we usually are out reading our sets or surface elevation tables. So that's going to show us our elevation change. And then I'll finish up with some water quality measurements. Here's just kind of a infrastructure map of the NER and what our Sentinel sites look like. So we have 6 surface elevation tables, one at the refuge, Goose Island State Park, a couple on Mud Island behind San Jose, Harbor Island and the mangroves, and then also, it's not shown on this map, but we have sets in Egery Flats on the west side of Copano Bay. We also have vegetation transects. A lot of times they are paired with our sets. So again, we're in one area, we have a ton of different monitoring going on. We have the elevation change, vegetation change, groundwater monitoring, as well as a number of people use our water quality station or our SWMP platform data. And we have 5 of those stations. Currently, the ship channel has still not come back online since Harvey, but we do have 4 other stations that have been pretty continuous since I want to say at least 2010. But those 5 stations are 2 in Copano, Aransas Bay, Mesquite Bay, and then again the ship channel that should be online by the end of the summer, hopefully. And so our MARSH monitoring happens at a number of different locations. I think we have 3 or 4 locations within the reserve system. And what we're doing is we have, each site has 5 transects and it's at least 20 meters long. We're actually, at some of the sites, we're expanding it to 40 meters so that we can actually cover into the kind of the upper marsh habitat now. So we can see how the lower marsh migration is going into the upper marsh, and we can cover that with our monitoring protocols. But we're looking at percent cover, and then we do stem density and then maximum stem height at all of these, at all the plots or the quadrats. So we have 20 to 40 meter long transects, and then every 2 meters we have a quadrat or a point. And here's just some photos of some volunteers and scientists out doing the counting and the percent covers. And this really gives you a view of how the sea level is changing within these habitats as well. So this is, in that larger photo, we have some water inundation, and then in that kind of middle, the lower photo, you see a lot of water inundation in our habitats lately. The last couple of years, people are wearing waders basically because they're just sitting in water for hours counting plants. And so now I'm going to kind of go over some of the data. And so this is Heron Flats at the Aransas Wildlife Refuge. So we're out doing this monitoring at least once a year. And that is just the photo of our site and the change from 2014 to 2018. And then I was out there 2 days ago, and so I took this photo, and this was a low tide photo. And so you're seeing just through photographic evidence the change in these habitats from 2014 to 2020. But then we're also able to provide actual data to support the changes that we're seeing. So in 2014, you can see there was a pretty diverse marsh habitat. You had a lot of Batis and Barrickia, Disticlus as well. And in 2018, that brown is basically the unvegetated amount. And so you had an unvegetated average of 6.8% in 2014, and that jumped to 53.73% by 2018. And in 2021, we have almost 83.6% of our plots are now unvegetated. We're actually to the point where I'm debating if we need to change completely, kind of just take photos of the site, but then also start monitoring another vegetation transect, because it's pretty easy, which I shouldn't complain that it's easy to monitor these sites now, but there's minimal vegetation there anymore to actually measure. And so what we can also do is we can take this data, so we're seeing the vegetation disappear, and we can pair that with our surface elevation table measurement. And these surface elevation tables are, or sets, are basically these rods that we have jackhammered into the ground to resistance. So basically they're going through all of the sediment to a bedrock. And then we put this attachment at the top of the rod, and you jackhammer, you attach another rod, keep jackhammering until resistance. If you walked up to one of these sets, this is what you would see. But then when we read them, I put this attachment on the sets, and I move those pins to the very top of the sediment. And so every year, every 6 months, we go out and I put this attachment, and we have scaffolding so that we're not walking anywhere near or around this area. And I can see with millimeter accuracy how the sediment is changing in that habitat. And so as sediment is coming in and out, the surface is obviously changing, but that placement of that rod is basically hard against the bedrock. So that rod is not changing in elevation. And so as sediment, for example, as sediment comes in, it's pushing up those rods. The rods will be higher. And so we're able to then measure, and it's literally just the meter stick reading from the top of the instrument to the top of the rod. And I'll show you some of that data here in a second. So we can take this data and pair it with the change in vegetation and kind of estimate to see or see if there's correlations or anything. We also put down marker horizons, which is basically just a layer of clay on top of the surface. And then we go back every year and we take cores. And so we can actually measure how much sediment has come into the system. So that white line in that photo is a layer of clay that we placed down 5-6 years ago. And we know the exact date that that layer of clay was placed down. And so we can see and then get an average of how much sediment is actually coming into the system. And I mean, so marker horizons only work for systems that have sediment coming in, which is not all of our marsh systems. And so here's just some of the set data that we have. And basically a positive line or a positive increase means that our, again, that means that there's sediment coming in, the pins are kind of getting pushed up and higher. And so a positive increase means sediment is coming into the system and you have accretion within that marsh or mangrove habitat. You can see Mud Island East on that third line is kind of all over the place. That was Harvey really kind of moved those sediment in that small little area. There was a ton of sediment movement following Harvey in that area. So those numbers are kind of all over the place. But having sediment come into a system may not be enough. So this graph shows that the gray vertical line is 0. So initially you might think like, oh, if there's positive and sediment coming into a marsh or a mangrove habitat, it's fine, like there's sediment coming in. But that blue line actually is it shows our sea level rise rate. And so we use the Rockport number and it's 5.62 a year. And so Aransas Refuge, you can see that, yes, there's sediment coming into the system, but it's not enough sediment to actually keep up with your sea level rise rate. So currently the only real system that seems to have enough sediment coming in to keep up with sea level rise is the Goose Island marsh. And again, Mud Island East is kind of all over the place. You had a lot of sediment move from one set to another. And you can see that with those numbers. And then Mud Island West and Harbor Island, where there's just not enough years of data yet to truly have confidence intervals for the analysis quite yet. Hopefully in the next year or two, we should have enough measurements. And so I'm going to quickly talk about some trends, water quality trends around the Mission-Aransas Reserve. So here's a photo of those swamp platforms. And again, there's 5 locations I had mentioned earlier. There's Copano East and West, and the purple circle just indicates that it also has a weather station on that station. But there's 2 in Copano Bay. There's the 1 in Aransas, 1 in Mesquite, and then here in Port Aransas on the ship channel, there in theory should be a swamp station or a water quality station. And at this station, we use Y-size sondes and we're taking 15-minute measurements various things. So you have water temperature, salinity, oxygen, pH, chlorophyll, turbidity, and then water level and depth. And all of that data is available. If you Google CDMO NERS, you have not only our swamp data or water quality data, but you can get water quality data from any of the reserve system wide. And then every month, either once a month or twice a month, they go out to the sites, and they also collect nutrient data, additional chlorophyll, and then zooplankton measurements as well. And so here's just some of the temperature, DO, and salinity data that we've collected in the last, since 2000, mid 2007 onward. And so you can see the temperature, you have the annual cycles. And you can see in 2017, 2019, we do have a break at most of our stations from Harvey. Oh, and I should say these only include Copano West, East, and Aransas Bay. This analysis that was done was really looking at the salinity gradient. So Copano West is closest to the Aransas River mouth, while Copano East is kind of mid area within our reserve system, and then Aransas Bay is the station that's currently closest to the ship channel mouth. And so it's just the three stations in this analysis. But you can see the annual variation in temperature, variations in DO, and then salinity. Going back, you can see variations in salinity, and then you can also pair that with discharge data from the Mission and Aransas rivers. And so these higher salinities are obviously times of drought or low flow into the bays. But during periods of high flow, your salinity increases along the rivers. And so the blue line, which is Aransas Bay, has higher salinities because that's farthest from the river's mouth. It's the ones closest to the ship channel. But then during times of drought that I was talking about, those high salinity periods, you actually have a reversal of the gradient. And so Copano West actually becomes more saline than the Aransas Bay. And so it actually, you can kind of say that like the Gulf of Mexico is acting as the freshwater source for these bay systems during times of low flow or drought. And so that's just some of the data and trends that we're able to see. Also looking at nutrients, you can see that there's large spikes of nitrogen under high flow conditions at Copano West, as well as phosphorus during those high flow stations. So one thing that we're looking to do is expand our water quality monitoring. And so we have these 5 stations, and we've actually maxed out with what data NOAA will accept from us. But we're really pushing to put online a 6th water quality station, which would actually be along the Mission River near Fennessy Ranch, which is within our boundary. And we want to do that for a number of things. We think it would kind of complete this kind of salinity gradient and provide a number of researchers and managers data from a river site all the way to the ship channel. It would provide educational opportunities for data analysis. And I just put this in. So this is a map that I showed you guys earlier from that project that was looking at your marsh migration. And the other reason why I'm really interested in putting the water quality station up near Fennessy Ranch, as you can see by 2100, even at only a ½ meter sea level rise, which is the lowest scenario they have possible, you see Fennessy Ranch becomes a salt potential for a salt marsh habitat. And so by having this water quality station all the way up the Mission River, we'll actually be able to potentially start monitoring for this this migration or saltwater intrusion up the river. And then I just wanted to finish up by kind of making a few final connections between sea level rise and water quality. We are seeing that we're loss of wetlands, and that seems to be due to increased sea level rise. We're seeing a lot of, every time we go out to monitor our marsh transects, they seem to be underwater. We don't have concrete evidence. We're still working on that analysis and need water level loggers, stuff like that. But with a loss of wetlands, you have a decrease in water quality. Those wetlands really are filtering out a number of nutrients, pollutants. They're keeping your sediment real with the root system, decrease in erosion, stuff like that. So with the loss of wetlands, you may have a decrease in water quality. Then you have a migration of estuarine organisms and habitats potentially upstream. And as they're migrating upstream due to sea level rise, they could be entering habitat or areas that aren't as pristine. They might be, there's obviously kind of a bottleneck as you go upstream to the availability of habitat, but then you're also potentially closer to sources of pollution, outfalls, stuff like that. And then you also have an increase in saltwater wedge up the river, which could impact your industrial and municipalities. So if you have cities that are dependent on rivers for water sources and they become saltier more often, that's going to impact city water supplies, industry intakes, and stuff like that. And then an increase in flooding, erosion, and inundation from higher sea level rises or higher sea levels. So if you're flooding these developed parcels, there's potential for increased pollutants or hazards to enter the estuarine waters and decrease water quality as well. And with that, I will take any questions.
Hi, Katie. Thank you so much. That was a great presentation. A couple of just follow-up comments here, but beforehand, I just wanted to remind folks, if you have any questions or comments, please to use the chat box and feel free to submit those there. So Katie, the reserve, a lot of folks don't have a lot of firsthand experience with that. So thanks for showing the pictures and sharing some of your experiences there in collecting data and doing research. So just wanted to start off with a general question about your experiences on the land there and doing monitoring. And I was just wondering, with your time there and with your colleagues, has there been like a field experience or something in particular that has stood out to you, provocative in one way or maybe endearing in another way?
Yeah, I mean, and I should have mentioned, like, one of the main reasons for these long-term monitoring is to, one, understand these long-term changes, but then also you're able to get out there and see these real quick, fast impacts. So with me, like looking at Heron Flats and watching the vegetation slowly like kind of degrade or grow away is one thing, but then also Hurricane Harvey, like being able to go out, we literally were at in the field the week Harvey hit, and then being able to go out directly after and seeing the immediate impacts was really kind of cool. And because I mean, that's what we do, is we're out there monitoring, so we're able to see those habitat changes immediately. So one of my sets on that Mud Island East site, it's really cool because I was literally trying to kind of research how to put an attachment on my set, because the sediment was coming in so much at one of the sets that I was losing, like I had maybe a half an inch, maybe a year left of reading that site before it was going to be buried. And then Harvey came and took out, I think, maybe 2 feet of sediment, to the point where I needed to actually go out and buy new pins because my pins were falling through the instrument. And so seeing that immediate shift in sediment from like one set to another was really kind of mind-blowing how much sediment could be moved in that storm.
Yeah, and the techniques utilized there with the set and then with the placing the clay out and then coring later, that was so innovative. Are those techniques that y'all developed there, or those borrowed from other folks doing that research?
No, the USGS folks are really kind of the leaders for that set protocol and methodology, and then NOAA's kind of adapted them, and so we're and I mean we have 6 sets, but there's actually a number, like the U.S. Fish and Wildlife have a number of sets in all of their refuge along the Texas coast. We recently published a paper with USGS to look at sets along the entire Gulf of Mexico. And so there's a map that shows you where all of the sets are located, but then also there's a gap analysis to know, one, what locations need sets, and then also what habitats are we not covering really well also. So USGS is definitely the leader on that one though.
In the beginning of your presentation, you talked about how the NER is tied into a network of other research reserves and how that system is looked at collectively when you're looking at data. Is that information, or is there a place where you suggest people could go and take a look to find more information about that approach?
Yes, so you can, there's 2 places, like I said, if you want the actual data, and that would be the water quality, vegetation, nutrient data, you can go to the CDMO, Centralized Data Management Office of NOAA. But then also the Neuroscience Collaborative is a funding agent within the NER system that funds internal projects, and a number of those projects are actually geared at analyzing on a national or regional basis that data. And so currently, like right now, we're working on a MARSH synthesis along the country, like system-wide synthesis of all of our MARSH data. So that project should be wrapping up here in the next year or 2. And so you could do Neuroscience Collaborative would have a number of the projects, and then your data access would be the CDMO.
So, pictures sometimes can say 1,000 words, as the saying goes. The before and after pictures that you had were striking. I believe maybe the first one was 2008, if I recall correctly, or maybe it's 2014. 2014, but the change since 2014 was incredible. But then you coupled that right behind the slides with the actual data itself. And so just kind of like with that in mind, and then also with in mind your slide that had the key questions components on there to be addressed. And so I'm kind of asking how this relates, and if your center or research reserve discusses policy, or if you have policy recommendations to the observations that y'all are seeing.
That's a good question. I mean, policy, I mean, conservation, I think, is our #1 kind of goal in policy. Is like there's nothing like protecting what we have, but then also it's a lot easier to conserve than restore, I think, is what a number of us are starting to realize. And so conserving what we have and really identifying those migration corridors. The sea level is rising, it's not going to stop. And so really being able to protect those migration corridors and give the marsh an area to migrate, I think, is really one of our big policies and pushes.
Thanks, and sorry if I threw you a curveball on that one.
Oh, no, you're fine.
We do have a question in on chat from Miss Williams. She asks, curious why Goose Island is tracking better at sea level rise, and can Katie tell us how the opening of Cedar Bayou affects the ecology of the area?
I'm not sure why Goose Island is tracking better. It could potentially be the they just put in that like breakwater area, kind of in oyster reef protection areas, and that marsh is a bit more protected than the one Heron Flats, which is on kind of the west coast of San Antonio Bay. So it could just be the protection, the oyster habitats, and then the breakwaters as well. And as for Cedar Bayou, I am not an expert on that one. I know we did, so the first time that they opened Cedar Bayou, we did have a circulation study to help understand the water circulation and changes that would occur pre and post that first opening. I'm not sure about the second one. I think in theory, it can only help by providing additional water circulation. During times of drought, it would only bring in kind of the fresh water, the fresher Gulf water, and provide additional water movement and circulation, which is always better for the systems.
We have one more question, and this comes from Mr. Saltmasters. Are beach migration corridors being measured and considered as well?
Beach migration corridors. I have not heard of that. I mean, I know the beach migration and changes in beach morphology and geology are being measured continuously. I will say one of our, and it's been identified recently and we're trying to work on it, is a gap, not only here at the reserve, but at the Marine Science Institute, is that we don't have any geologists. The geologists actually work at the Geo School in UT Austin. And so we're starting to really build that partnership to bring the UT Austin researchers that are doing the coastal beach change research out to Port Aransas more often, so that we can partner with them more closely and kind of get more involved and build bridges there.
Thank you. And we that question might also relate to our fellow program in the General Land Office, the Coastal Erosion Planning and Response Act program. Manager Kevin Frenzel, and I just asked him, he might have a chime in on a response to that question as well. The question on sea level changes in other locations, we did have a NOAA presentation earlier in this year related to the lunch and learns. And that presentation did talk about Texas regional changes in sea levels in different areas, as well as comparisons to other parts of the country and the world. So feel free to please take a look at the past lunch and learns from this year, and you will see that presentation available on YouTube. We have another question here. Thank you for the great presentation. Looking into those graphs, it looks like there is a significant increase in unvegetated habitat between 2014 and 2021. Is this unvegetated habitat mostly converted to estuarine open water, or is it to some other habitat type?
It is mostly like more of a salt flat habitat. We do record some seagrass starting to come into those unvegetated areas, which it's pushing our protocols into a different realm that we're not normally, because normally we just do percent cover. So now I'm doing, okay, it's 20% water, but then what's under the water? And so then we're adding another column of there's 18% haladuli and how much just plain sediment. So the transition is transitioning to some seagrass, some just salt marsh, mud habitat, not salt marsh, sorry, but mud, salt flat habitats.
Well, it looks like it's all the questions for now. Ms. Katie Swanson, you've done a great job with your presentation and sharing unique insights to what's happening there at the NER. I really do appreciate your time and preparation for this. So thank you so much.
Thanks for having me.
Absolutely. I also like to thank our collaborators, the Texas Sea Grant, Texas Community Watershed Partners, and Meadows Center for Water and the Environment. I'd like to thank our co-host and facilitators for this event, Meadows Center for Water and the Environment. We will be back with you next month with another Lunch and Learn. And as always, we're readily available to your questions and comments. We continue to look for partnerships and collaboration around the Texas coast to work on sustainable stormwater drainage and non-point source pollution. My name is Jason Pinchback with the Texas General Land Office. Thank you so much for joining us today.